All right, welcome back to the second Elsevier Symposium with the theme Excellence in Research and Teaching, Positive Impact on Society. I'd like to invite our keynote speaker, Professor Dr. Long Kai Sang from the Singapore Institute of Technology to present his speech with the title Innovative Learning and Research Problem Solver for Industry. And I would like to welcome Prof. Kang.
Good morning, everyone. Yeah, because just now I jot down some opening remark, but then I didn't see the VIP are supposed to address, so I would dispense of that. Yeah, so just said, well, good morning, fellow academia and fellow engineer and researchers. Thank you for the opportunity to be invited to do some sharing on this topic of innovative learning and research, problem solver for the industry. Yeah, it is a subject quite close to my heart, solving industry problem. Yeah. I started my technical training Maktab Teknik Janan Kerni quite a long time ago. I received my diploma, quite happy, first class diploma from Maktab Teknik Janan Kerni, and from none other than this Tun Hussein On. At that time, he was the Minister of Education. So, being a student, the 3-year diploma, Maktab Teknik, one of the memorable experience I had was to go for internship in the Rumping mine, because I have a scholarship from one of the company. I came from Bahang, so entitled at that time to apply for scholarship from this Rumping mine, iron mine at that time. Now I know they already closed. So a condition of that scholarship is to go for internship in the mine. Wow, that was 1969. Really isolated from the rest of the world in an iron mine, in Bahang, in Rumping. But then the experience was memorable because, as a teenager, just go to, college, Maktab Teknik or Polytechnic. Then you know so little about the technical subject. So you go for internship, what can you do? So my supervisor asked me to, okay, put a handkerchief, put on your nose and mouth, take a blower to blow off the dirt and dust from those motor-driven system, because you need this conveyor belt to bring the iron ore from the mine, conveyed some distance away to be loaded and so on. Dirty job. But then I understand that, well, when you got dirt covering your equipment, that equipment can get overheat and so on. So those was a lot of motor-driven system. Then I get fascinated about this motor electrical stuff, and yeah, because I was a diploma student on electrical engineering. Subsequently, I get quite fascinated by this electrical machine. So subsequently, I went to UK. I got my degree and then my PhD, also working on electric motor related. It's just somehow. And I must mention that, yeah. So subsequently, after my PhD, I joined NUS as a young lecturer. That's in 1980. But then after 17 years as an academic, I found, well, do I want to continue as an academia? just doing research and teaching and writing paper just for the sake of ranking and get promoted. I was very disillusioned, mid-career blue, I would say that. So I left NUS, I started my consultancy, and then solving real industry problem. Very happy, but then subsequently, when I getting a bit older, about to go slow, a new university, Singapore Institute of Technology, they focus on applied learning, applied research. So they approached me because my NUS colleague now became the president for the new university. They said, hey, Kai-sang, you have that academia plus industry experience. You want to come back to academia or not? But then when you are in the industry, work can be quite tough. When I was younger, I can climb up the oil rig to do troubleshooting and so forth. But you get older, when you reach almost over 65, I'm more than 70 years old now because I got my diploma from Maktab Technique in 1971. You know how old I am. Yeah. So when I came back to the university, I now champion this Energy Efficiency Technology Center and driving sustainability. But then sometimes people say, hey, Kai-sang, you still look energetic. Then I jokingly said that, wow, because I'm working on sustainability, I got to sustain, continue. So there's no retirement age now, So long as I have value to the university and university want me, I will continue. Very meaningful, doing energy efficiency, low-hanging fruit for the sustainability. Yeah. Okay, talking about solving industry problem. Let me just to give this example. So when I was as a consultant, one day I received a phone call. One of the oil rig builder in Singapore. The build is semi-submersible. Commissioning in the open sea, about to deliver, everything ready, sea trial. But overheating the thruster, $500 million US on the sea drive, cannot deliver, can only run at 90% of the speed. Of course, the owner do not want to take it. You cannot deliver 100%. This rig can only go to maximum 90% of the so-called stipulated speed. Supposed to be able to test 110. Very hot. The 5 megawatt motor, very hot. And of course, a vendor, I don't know if it was ABB or Siemens, they have a team of engineers doing troubleshooting. Because the LD, liquidated damage, not able to deliver $500 million US, could be very a lot every day. So they asked me, maybe they tried their luck. They say, hey, Kai-sang, can you come to go on board, help us to troubleshoot, because the normal engineer cannot do it. Because I have the academic background, understand the principle. So I put aside everything, take a speedboat, 2 hours to catch up on this rig, get lifted up. Quite interesting. And spend 25 hours non-sleep doing troubleshooting. Working along with a team of engineers from those vendor multinational company. And then at 25 hours, then I said, I find a solution. So simple. See, a lot of the industry problem, not that complex. When you find the root cause, this one example. For electrical guy, because of this electrification, so the thruster get overheat because they're using this big motor using variable speed drive. And 5 megawatt each motor, very big. It gets very hot when you try to go above 90% of the speed. You ought to test it up to 110%, 90%. Because the original team of engineers, their focus very narrow. They look at the control algorithm, is there any bug, what's wrong with it, and so forth. They are not able to look at it as a system. So, because initially I don't know what's going on. I put out the work, go up. That's why initial part of the 25 hours to ask, hey, what happened? And finally, I just said that, well, so easy. For the electrical guy, you just need to adjust the transformer tapping to help it increase the voltage. Because the rig is very, very long. So you have a distribution, a long cable to deliver the power to the big 5 megawatt motor. So there was a lot of voltage drop to the long cable. And by the time the voltage at the terminal of that system is too low. And when the voltage is too low, even after the conversion, the voltage is not enough. But you need to deliver the power. Voltage not enough, you want to deliver the same power to the transistor, you draw a larger current. Voltage not enough. When you draw a larger current, the Ohm's law, I square R losses in the motor, in the winding, become higher. Therefore, you make the motor very hot. Very fundamental principle, but a lot of so-called experts not able to link it together. So I remember that case. So 25 hours later, I said, I've got a solution. I get up from the rig, and then I just see my employer. And then subsequently, I explained to them. And finally, I sent a bill. I still remember. I sent a bill, 9,200 Singapore dollars. And then the company, the engineer said, hey, Kai-san, you just went up. Today you went up. Next day you come down. Wow, 9,500 Sing dollar. At that time, the conversion rate to ringgit is not so high, not 3.5 1 Singapore dollar. 9.2 thousand Singapore, still quite a bit. Then the guy said, hey, I said, come on, man. I help you to solve a problem. Every day your liquidated damage, I don't know how many thousand. It's not one day job. 25 hours non-sleep, and I provide a solution. It's not just my manpower. And I tell the slowly to my friend. My friend said, you solve problem. Don't tell people, I find the solution. People don't pay you. You must tell them that, wow, very complex problem. I got to bring my team, all the balang bring on board, go there for 1 week, send them $100,000, they will be very happy to pay you. But then, I teach at the University Engineering Ethics. And I said that, I cannot teach people like that. Nah. I can solve it 25 hours in 25 hours. So, I just tell you. But this sort of problem is there. What I'm trying to say that when you solve industry problem, for electrical guy, no need to go and solve Maxwell equation, partial differential equation. Those are not much of a use to the real industry, isn't it? Yeah, able to make sense from the fundamental engineering principle. In fact, exactly the same. This year, because of energy efficiency application. So one of the facility that installed this motor called EC motor, electronically commutated motor. It's a sort of brushless DC motor to have variable speed drive for air handling unit so that we can control the speed and so on. But once you use a new technology, maybe I get a piece of water. I think it's okay. I just drink from here. I think all this My colleague, I think it's not important just to drink from the bottle. So this is a new technology, energy efficiency. But after installing this EC motor with electronic control, then they find that that room, when the cable run through, make noise, vibration. And of course, office worker, when you make noise, how to the cable trunking, people get worried. Even those are not too noisy. So then the question is, now what causes this mechanical vibration, this sort of noise, when you employ a certain technology to do so? Then, the ordinary engineer don't know how to know. They say, hey, what causes that? Huh? You employ a new technology, got problem. Then to us, we understand the fundamental principle. Yeah, quite straightforward. When you got conductor, it carry current, there is electromagnetic forces between them. And when you use a variable speed drive, you got harmonic at different frequencies. So you got two, one conductor may have fundamental, you got the harmonic frequency interact. So you got different, these vibrating forces. And when you interact and then you get into the mechanical resonant frequency, of course you can make very noisy. So the solution, use harmonic filter. Okay. So install harmonic filter. But once you install harmonic filter, alamak, that motor, now EC motor cannot deliver your power. And it get hot when you try to push it. You see, when you do a solution, it got problem. Then they say, then they came back to the Prof. Locke. They said, Prof. Locke, you said that you put harmonic filter, you can solve it. See, now you cannot solve. Don't pay you your consultancy fee. Sometimes you got this problem, They want to guarantee solution. But then I said, hey, what type of harmonic filter you put? They said, well, we put this type. I said, you put that harmonic filter, you got a series joke, how you put something series, you put something in series in the electrical circuit, then you causes a voltage drop because you affect the motor performance again. So I told them that this type of filter is not good because when you include the you insert that filter in series with your power supply before you go to the EC motor, you create a voltage drop. But you try to filter, and therefore your voltage supply to the original EC motor without the filter, it was the normal supply voltage. Now the voltage lower. So I asked them to do a measurement. That should be the case. Yeah, they did. They said. So then we said, well, you cannot use this type of filter, You got to use the active harmonic filter. You don't put something in series with the power line because that can fundamentally, when you connect something in series, the circuit, just like you connect two resistors, three resistors, each resistor you connect in series, you create voltage drop, so that the voltage is not sufficient. Then when they put the active filter, it worked. Then I got my consultant fee. Not that much because it's an easy thing to do. What I'm trying to tell the story is, industry problem, sometimes people don't know it. It looks complex. But once you understand, you can relate the fundamental principle. It's straightforward. But it's good, even though as a professor, I still sometimes go to do some easy consultancy and charge some extra do it to buy some gift for my wife yeah. So I like to solve industry problem, real problem. But sometimes you need to apply different mindset. It's not just to apply. Don't always don't look at equations, some equation. Look at the system viewpoint first. Just look at it. Sometimes we have a lot of the know-how to help industry already. You don't sometimes need to do a lot of research to find out the solution. What I'm trying to tell you is that, So if we look at the engineering education, what we are supposed, engineering education is intended to prepare students with the knowledge, not just knowledge, skill, and the mindset required to excel in the field of engineering work, do real engineering work. Engineers need to have a set of competence that enable them to apply the knowledge, skill, and attitude to solve real world problem. It's not just a problem in the lab. Make decision and achieve defined goals. Right? And yeah, of course nowadays engineering education, the way that we deliver, we structure engineering education, make a lot of changes. We focus on interdisciplinary, very important, yeah, because sometimes to see the real problem, you got to look at things from a different perspective. Hand-on and project-based learning, important, incorporate of emerging technology. Many of this require. So I will not go into all the details because you guys are also academia, you know what I mean here. So whatever I put on the screen, I think you know them very well also. So I'm not going to go to that sort of theory. Adaptive learning, I think technology, now we can do customized learning for the student. And yeah, innovative learning in engineering education. Now, what we're talking about? Of course, when we use our technology, go a long way. So I think now with the technology, it makes life easy for us and academia. So we don't need to just spend too much time on delivering the content. I think there are a lot of content. I think we can give them to technology. I think more is to excite the student, make sense of the knowledge, how to apply those knowledge, to do that. And that we need to have that sort of industry interaction. Yeah. Yeah. So there are pedagogical transformation. We look at more active learning now. It's not passive. I know that in the old day, when I was a young student, we that time no computer. I did my PhD. I got to use a pan tip. You still do not have the normal computer. And every time I run my analysis, PhD analysis, the accountant department get into problem because I take a lot of the computing time from the shared computing facility. But now, very different now, of course. Problem solving, adaptive learning, all this lifelong learning, very important. I will not go on. So, yeah, there are different ways to design the pedagogy to impart competence, not knowledge, how to get things done, how to solve real-world problem. Of course, we need to do research to generate knowledge, to advance the knowledge. But that knowledge, as academia, we do the research not just for the sake of research. We learn from the research. We have more frontier, up-to-date knowledge, and how we can package this sort of knowledge and deliver, impart them to the student. You see, as an academia, when we engage in active research, we have that confidence. Because you're not copying from textbook. You done the work. You thought through that sort of knowledge sphere. You become somebody, you know the subject very well. When you deliver the subject to the student, you speak with confidence. Student asks you a question, you can explain, you can think of the real life situation. So I think it's important how to link applied research and applied learning. Yeah. I'm the chairman. This June, I took on as the chair for the Washington Accord. Probably those are dealing with engineering education. You know the importance of going for accreditation, and yeah, so this is something that we do. So we stipulate the sort of learning outcome for engineering program, not to stifle the way the curriculum structure, teaching learning outcome, should be delivered, but rather we stipulate those learning outcomes that we treasure based on the real-world requirement. So we come up with this so-called graduate attribute. And we want engineering program which want to have international mutual recognition to comply with, ability to apply engineering knowledge, able to problem analysis, complex engineering problem. So those it's quite subtle when we talk about complex engineering problem. Again, from my half my time, 20 years as a consultant solving real-life problem, I find that, that ability to see simplicity among the complex issue, that is something very, very important. Because you don't look at problem just to say that this problem is complex in itself. I thought I have some extra because we start 10 minutes late, so I think I still got a few minutes for my half an hour delivery. Yeah. So yeah, we have this graduate attribute that we need to adhere to, and then including the attitude, ethics, all those important areas. Yeah. So these are the one that we want our student engineering graduate to acquire. Knowledge, problem solving, and also the skill-oriented attribute, and the attitude as well, because very important. A well-rounded graduate. So, okay, how we deliver to make a problem solver for the industry. And I think I will share what we are doing at our new university. SIT is a very new university in Singapore, and applied learning, applied research. We make ourselves different from NUS, NTU, or Big Brother. So very new. With this, so we are going to move next year to a new Punggol campus with a lot of exciting things with microgrid nearby. We have our Jurong Town Corporation. So we next door. So during the office lunch, we can move between the industry park and our campus, digital park next to that. Also, our location, actually we are immersed in those industry setting, new campus. And we value that applied research. We have the bridge between industry and the academia, and effective learning through that. And we have students who went for industry attachment, not 2 months, 3 months, 6 months to 1 year. Now we standardize all our engineering students attached to industry for 8 months, enough time. Because you go for 1, 2 months, 3 months, people just go there, look see, think of such and then they don't learn the real thing. Enough time, 8 months. And then we do that. IWSP, we call it IWSP, industry. And we also stipulate what type of a skill set, the sort of framework. So we, university-wise, we look at what type of industry-ready frameworks, hardcore, soft skill, and so forth. And then, yeah, we also, those soft skill, transferable skill, critical skill, and so forth, adaptive. Yeah, so this across university-wise requirement, not just engineering, yeah, sustainability, transferable skill, we across the board. These are very important. Once the university determine it, make life easy for the engineering program. And then for individual students, we do tracking on their progress and so on. We do this sort of tracking, and yeah, we require this digital competency, design, social. We also require students to have a module, social innovation, understand the role of an engineer in the society, compulsory module, yeah, and then industry ready, and innovation hub. All this together with the student academia, we can create classroom prep, real work environment, work with the industry. We create just an ecosystem to reach out, to connect with the industry. And yeah, apply research, apply learning. And we focus also on the sustainability. Yeah. And level 1, level 2, level 3. So we map up not just for one program, university-wise, faculty-wise, school-wise, those level, sustainability. We do micro-module to build up that sort of credential, sharpen, enhance sustainability content, and yeah, sustainability. Let me just share. I'm hitting this energy efficiency. So we play a big role. I also take in students now, 18 students with me, go to 8 months training. So we help industry. We conduct energy. I employ full-time, 10% go to industry, look at the energy portfolio, and we do apply research to help them to solve problems, not just doing computer simulation, go to the real industry to help them. And then, then we bring students to work along. We have full-time energy specialists, 10 of them. And I think with this sort of able to do the real thing, can only connect well with the industry. Apply learning, apply research, able to do things. And so social innovation project as well require students to work on it. And so apply research. We don't focus on the front end. We know our position. We said we do apply research. Those 4, 5, 6, all these are translational. We leave NTU to the other side because we don't need to compete with them. So I think that's good because we do the other end, translational. We connect with the industry well. And we do all this just like you, but more apply. We define our position to do that. And okay, I think with that, thank you very much. Thank you.
Thank you very much, Professor Dr. Lok Kai Seng from the Singapore Institute of Technology. Ladies and gentlemen, if you have any questions, we will have later.